everybody. Welcome to my videotaped lecture right here in my kitchen. So today, I'm not taping this on Friday, but you'll see this on Friday. I don't even know what day it'll be. You're going to be starting Unit 3, which is all about petroleum, but Section B is about how we use petroleum for burning. The other way we use petroleum is for building. If you remember from your reading assignment, building, like we use those hydrocarbons as materials. We use the molecules to create new molecules, and we use them in manufacturing. That's the building. But in Section B, we're talking about burning. And so remember from the crude oil and fractional distillation video, you read about how we call the crude oil buried sunshine because of where the crude oil came from. I want you to remember this is all about energy. So at one point, these prehistoric plants were on the surface of the earth. Look at my beautiful drawing. Aren't you missing it? And they, through photosynthesis, took in energy from the sun. And now they're storing that energy in those plants, right? And so those prehistoric plants, over time, get, oh gosh, bear with me, buried under rock and sediments, and because they're buried under that, they're experiencing a lot of heat and pressure, and that's how those plants eventually turn into the crude oil, but they're from like the fossils. That's why we call these things petroleum, the natural gas, and the coal are all fossil fuels because they came from these fossilized plants. But remember, those plants are holding all that energy they took in from the sun. Now, when we pump that crude oil out of the ground and we refine it, we can use all the parts of that crude oil. We can use all that petroleum for different things. Again, the burning or the building. But that process that causes those, old plants buried under the ground to turn into the crude oil, that process is so slow compared to how quickly we're pumping out that crude oil and how quickly we're, going through our supply, that we don't really consider that a resource that is renewable because that process takes so long. We're using it up much faster than it can be produced. But when we are able to, when we do take that crude oil out of the ground and we, do that fractional distillation where we refine that and we separate that petroleum into the different fractions, right? All those little mixtures of hydrocarbons. Remember, you've got those short chain hydrocarbons that have really weak intermolecular forces, so they're gases. The really long chain hydrocarbons have stronger intermolecular forces, so they're really attracted to each other. So those are things like liquids, or the even longer carbon chains. You've got solids, things like the wax that you have in your candle, that when you burn the candle, that wax is the fuel for that candle. And so the reason that we burn these hydrocarbons is because in that burning process, when you burn them, they produce or they give off a lot of energy. So I just want to talk about this energy. So I'm going to use this as an example, right? Our simplest hydrocarbon is methane, right? And it's that one carbon bonded to the 4 hydrogens. And remember, for burning to occur, the other reactant that we need is oxygen. And when a hydrocarbon burns in the presence of oxygen, we always get carbon dioxide and water. Now, hopefully you're looking at this and saying that's not balanced. We know that this, of course, is going to follow the law of conservation of matter, so I'm going to balance this by doing this and doing this. And remember what that means is that you've got this methane, right, one carbon methane, you've got all single bonds, reacting with the oxygen molecules. And I know the oxygen molecules look like that. They have that double bond. Now, after the change what's happened is this is a chemical change. The atoms rearrange and form new products. The way that we get these things to turn into these things, right? There's my carbon dioxide, here's my water. I've got 2 molecules of water, so I'm going to draw a second one. But in order to get this and this to react and rearrange to form these new products is we have to first break the bonds of the reactants. Right, so here I am breaking bonds. I'm putting in a little bit of energy to break those bonds. And then these are all rearranging, right? My carbon is hooking up with oxygens to make carbon dioxide. My H2Os are coming together, right, to make H2O. Here's another H2O making another molecule of water. But in rearranging, we're forming new substances, new products. These reactions where we're burning the hydrocarbons, our products are at low energy, but our reactants are at a high energy. And this is what I mean by that. My reactants were storing a lot of energy in their bonds, right? So stored energy in bonds, right? And a stored energy is what we call a type of energy called potential energy. So the methane, the oxygen are holding on to a lot of energy inside those bonds. Well, my products, they're not storing as much energy in their bonds, so that when this burning takes place, this whole process is releasing that extra energy out to the surroundings. And that's why these are called exothermic, right? Because in burning, what I'm doing is I'm really releasing to the surroundings that large amount of energy that was stored in these bonds. Because the new products are not storing as much energy in their bonds. So that extra energy has to go someplace. It's given off to the surroundings. Every time you burn a hydrocarbon, those reactions are always exothermic, which means the therm, or the heat, is exiting, right? A reaction that's endothermic is where that reaction pulls in energy from the surroundings. So if you're in the surroundings, you're going to feel cold. Whereas if you're near an exothermic reaction, like a campfire, that's a burning, you're burning the wood, that's going to feel hot to you because that is an exothermic reaction, because burning is exothermic. You'll feel that heat being given off. What did I say? So anytime you burn these hydrocarbons, you're releasing energy. But what I want you to remember is where that energy originally came from. Well, for these hydrocarbons that we get from the crude oil, the energy that, for example, methane is storing in its bonds came from when it was part of a plant on the surface and it was taking energy in from the sun. So the energy that we get out of burning those hydrocarbons is energy that really came from the sun.